Alrighty, in this video, we're gonna take a more in-depth look at that multiplication rule that we briefly touched on before. So to do that, let's recall the formula for a conditional probability. We said the probability of B given A is equal to the probability of A and B divided by the probability of A. Well, if we multiply both sides of that equation by the probability of A, so imagine you just came to both sides of that equation multiplied by the probability of A, that would give us precisely what we call the general formula for the multiplication rule. And it says the probability of A and B is equal to the probability of A times the probability of B given A. Well, you're probably saying, Professor Dixon, that's not the formula that we saw earlier. We saw the probability of A and B is the probability of A times the probability of B. Well, the key point there was that they were independent events, right? And if you recall in our independent events video, we said that, oh, the probability of B given A must equal the probability of B. Well, if I take that probability of B and substitute it for the probability of B given A into the above A and B formula, you get precisely what was introduced to you earlier in the term, right? Okay, but for the sake of this particular homework, we're going to focus on this kind of general form where our events are not necessarily independent of each other. Before we jump into a couple of examples here, I want you to take a quick note. So when it comes to, so as you can see, the difference between the two formulas really depends on, do we have a set of dependent events, which leads us to the general formula, or do we have a set of independent events, which leads us to the kind of simplified version of that, right? Well, it turns out that if you're ever in a situation where you're selecting things without replacement, and what that means is, let's say we have a deck of cards, and I'm selecting one card, and I'm not returning it to the deck. What I'm doing is I am keeping that out of the deck. That is what we call without replacement. Well, what happens is anytime you don't return something to the deck or the pile, you're creating a different probability for an event to happen that leads to a set of dependent events. So anytime you do not replace something, you're going to have a set of dependent events. However, if I select a card and then I put it back into the deck and reshuffle the deck, I'm now back to square one, and now I have a set of independent events because whatever I selected doesn't really matter because it doesn't affect my next selection because I put it back into the deck. Okay, so just keep those in mind. All right, a couple of quick examples here. So suppose we bought a small bag of candy. There were 20 total candies inside. There were 7 green, 5 orange, 4 red, 3 yellow, and a single purple one. What's the probability that your first 2 candies are orange? Okay. So what I want us to do always is to label our events. So if I need to select my first 2 candies to be orange, what happens is event A is that I need the first candy to be orange. And event B is I need the second candy to be orange. Okay? And since I'm selecting 2 candies, this is going to be an example of without replacement because as I select that first candy, I'm not replacing it, right? Because this is going into my mouth. I don't know about you guys. All right, so this is an example of without replacement. So really event B is the second candy is orange given that the first candy was orange. That's really what needs to happen in that event B, all right? So what we need is the probability of A and B, all right? We need both of those to happen. We need the first candy to be orange, and we need the second candy to be orange, given that the first one was already orange. And so as we saw earlier, that formula is the probability of A times the probability of B given A. Okay? All right, so what does that equal? Let's talk about the probability that the first candy is orange. How many total candies do we have in our bag? Well, we have 20. That's our denominator for the probability of A. How many of those 20 candies are orange? Well, they tell us 5 of them are orange. So the probability that our first candy is orange is 5 out of 20. All right? Next, we're going to multiply it by the probability that the second candy is orange given that the first candy was orange, right? Well, now, remember, this is without replacement. Now that I've selected that first candy, I now no longer have 20 candies in the bag. I now have 19 candies. Out of those 19 candies, how many of them are orange? Well, I started off with 5, but I've already taken out 1 orange candy. That leaves me with a total of 4 orange candies. All right? So once again, that second probability is going to be 4 out of 19 because now instead of 20, I have 19 candies. And instead of 5 orange candies, I have now 4 orange candies. All right, so what does that equal? Well, we take 5 times 4. That will give us 20. Remember how we multiply fractions. Multiply across the top. And then if I take 20 times 19, that should be 380. Let's just double check that. 20 times 19, yeah, it's 380. Okay, so we have a 20 out of 380 chance of selecting our first 2 candies being orange. And if we want to convert that to a decimal, just take 20 divided by 380, and we get a 0.05, let's say 3, if we go to 3 decimal places. Okay, so a little over 5% chance that our first 2 candies are orange. Okay, what is part B? What's the probability that your first 3 candies are not green? First 3 candies are not green. So let's see here. So once again, event A is we need the first candy to be green. Or not green, right? Not green. Then B is this, we need the second to not be green. And it's the same thing. This is without replacement. And we need C. We need the third candy. Event C is, let's see. C is that the third candy is not green. Okay. So what we need is the probability of A and B and C, right? We need all of those. Okay. Well, don't worry about it. It's just simply going to be, remember, it's the multiplication rule. It doesn't have to be just for 2 events. It could be 3 for however many events. You're just going to simply multiply all the probabilities of all the events occurring, okay? All right, so let's see here. What's the probability that the first candy is not green? Well, let's see. How many green candies do we have? There are 7 green candies. Therefore, so let's come over here. So there are 7 green candies. And there's a total of 20 candies. So that means that there's 20 minus 7, which is 13 that are not green. And that's going to be important for us. So what's the probability that the first candy is not green? Well, there's a total of 20 candies when we first start, and 13 of them are not green. Okay. Remember, this is without replacement. So that means when we go to the next selection, there's no longer 20 candies. There's now 19. And since the first candy was not green, that means that there are 12 remaining candies that are not green. Times, now for the third selection, we have only 18 candies remaining. And how many of those are not green? Well, because the first 2 were already not green, that means there's only 11 left that are not green. So now, I definitely need the calculator for this. We are going to multiply those numerators and denominators. So 13 times 12 times 11 is 1716. divided by, let's see, 20 times 19 times 18 gives us 6840. All right. And so what is that written as a decimal? Let's just take 1716 divided by 6840. And to 3 decimal places, we get a 0.251. So there's a close to 25% probability that our first 3 candies are not green. Okay, moving along. Last question here is, what is the probability we roll 2 consecutive 5s when rolling a single die? Okay, so now this is a situation where, this is done with replacement essentially, right? Because whenever we roll a die, we can't really take it out, right? So anyways, so what's the probability we roll 2 consecutive 5s when rolling a single die? Okay, what are the 2 events? Well, the first event, A, is that we need to roll a 5. Roll a 5 on the first roll. Event B is that the second roll needs to also be a 5. Okay. We are trying to find the probability of A and B. So how do we do this? We take the probability of A, the probability that we get a 5 on the first roll. Remember, when we roll a single die, it has 6 values, right? 1, 2, 3, 4, 5, and 6. What's the probability we roll just a 5? There's only 1 5 in that sample space there. It's 1 out of 6. Times the probability of B. All right, so this is the probability of A. What is the probability of B? Well, it's also going to be a 1 6, right? Because when we roll that die, we still have 6 outcomes, and only one of them is a 5. And this is the probability of B. Whenever you roll a single die, it's going to be a set of independent events. Okay, so anyways, 1 out of 6 times 1 out of 6. 1 times 1 is 1 out of 36. So that is our probability of rolling 2 consecutive 5s. Alrighty, folks, this is it for the multiplication rule. Look forward to seeing you in the next video.